In this video, we're going to learn how to draw structural diagrams and line diagrams for alkanes from their names. Before we do that, though, I want to do a warm-up naming one. So here is a picture. And I want you to name this compound. So pause the video, try it out, and then we'll take it up. So I would try to find the parent chain first, and it looks like this is a pretty easy case here. Just a linear parent chain like this. That's the longest chain that we have. And that would be 1, 2, 3, 4, 5, 6. So it's a hexane parent chain. That's pretty straightforward. But then this part here is a little bit of an interesting scenario. We got a number, and if we number, you get the lowest number here. Your substituents are at number 3. Notice that this is two separate substituents. You have a methyl here and a methyl here. So you have two methyls at the same carbon. And there's nothing wrong with that. It's just the numbering is a bit interesting when you list it. So this is at carbon number 3. So you would say 3, and each methyl wants their attention. They get their attention. So that's for one methyl, then comma, 3 for the next one. Doesn't matter if it's 3 again, because you're trying to say I have two methyls at this location. So 3, 3, and then dimethyl, and then hexane. 3, 3, dimethyl hexane. So just remember that. That's a common situation that happens. So now you know how to do it. So let's go ahead and do some drawings. I'm going to first start by doing the line diagrams for the examples, and then we'll move on to structural after. So we'll start with butane. If you do a line diagram, I always put my pencil down first. That's carbon number 1. And then I go up. That's carbon number 2. And then down, carbon number 3. And then up, carbon number 4. So start counting as soon as your pencil hits the page. You could have also gone the other way if you wanted to. You could have done carbon number 1, 2, 3, 4. And that's fine as well. Same molecule, just kind of rotated around in space, but same thing. Okay? Okay, so, and we have no double bonds, no triple bonds, because it's an alkane ending in ane. So now we're going to try to do a structural formula. When you do a structural formula, the first thing you need to do is draw your carbon chain, just like we did for the line diagram, actually. And then if there's any substituents, you would add those. But there's none in this case, just butane. So we draw our carbon chain. So draw your carbons all connected to each other. And then go and add H's until every carbon is happy. And every carbon is happy only when it has 4 lines connected to it, because carbons take 4 bonds. So this carbon at the end over here already has 1 line. It needs 3 more lines. So it takes 3 more H's. This carbon over here already has 2 lines. So it needs 2 more. Same with this one. And this one at the end needs 3. And it makes sense. The ones at the ends will usually need 3 in alkanes. And then the ones in the middle will usually need 2 because they already have an extra carbon from the neighboring carbons next to it. So there is butane drawn as a structural formula. So you can try the next one, pause the video, try it, and then unpause and see if you're on the right track. So as we're taking up, we'll start with the line diagram first. 1, 2, 3, 4, 5. You don't have to put points like this. I do just to help myself remember that I've drawn all the points, all the carbons there. You could have also drawn it the other way instead. You could have done starting here and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I made a mistake. I added an extra carbon accent because I forgot to count as soon as I landed. So you got to be very careful with that. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is pentane. Now for the structural formula, draw your carbon chain. 1, 2, 3, 4, 5. All the carbons at the end need 3 hydrogens. The terminal carbons, we call them, because they're at the end. And the carbons in the middle need their 2 hydrogens each to get the full 4 bonds. If you have less than 4 bonds, like 4 lines connected to carbon, you've done something wrong. If you have more than 4 lines connected to carbon, you've done something wrong as well. Remember, carbon, it does not have incomplete. It does not have expanded. It has just complete octet. All right. Now we have a situation where we have some substituents there. So we're going to do the bond line diagram first. First thing you want to do is you want to draw the hexane parent chain first. So let's do that. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you choose the number from any direction. Doesn't really matter where, because whichever way you go, it still gives you the same answer, just kind of drawn in a different orientation. So we have 3-ethyl and 2,3-dimethyl. So I'll just start counting from here. So we have 1, 2. On carbon number 2, we have a methyl. Then 3. On carbon number 3, we have a methyl. And we also have an ethyl. So like that and like that. That's the ethyl. And then 4, 5, 6. Okay. It doesn't matter if you put the methyl here or here. Like if you switch these around, that would have been okay. You're fine. It would have been the same molecule because these molecules actually rotate in space and they spin around the bonds. So the other version can exist. Doesn't really matter. It's not a different version. It's just a different view of the molecule. Okay. Somebody else might have done it this way instead. They might have done kind of the similar skeleton. So 1, 2, 3, 4, 5, 6. But they started counting from the other direction. So they have their 2-methyl over here. And then their 3-methyl. And then their 3-ethyl. So now we're going to draw the structural formula. So we have hexane, 1, 2, 3, 4, 5, and 6. I always put my carbon outline first. Then I have my, let's just count from the left side. On carbon number 2, I have a methyl. And I'll draw it like this, CH3. On carbon number 3, I have a methyl as well. And I'll put it over here, CH3. And then I also have an ethyl. The ethyl would be CH2, CH3. That's how you write ethyl. Make sure you review that in the table. Also, if you would have done CH3, CH3, it would have been wrong because then this carbon would have had too many bonds on it. So be careful there. So CH2, CH3 for ethyl. And then you can go and you can put in your other hydrogens. You should actually technically have expanded all these over here, so drawing all the H's out individually. Really, when I have substituents like that, I don't. I just keep them kind of condensed. You're allowed to do that. And in fact, in many diagrams, I don't mind if you do that condensed. Like if you had this H3, H2, 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 H3, I'm okay with that as well. This is a condensed structural formula where instead of drawing all the hydrogens expanded, you kind of condense them so it's a bit less to draw. You just have to make sure that you have put the correct number of H's in there. And it's easier to see that when you have the expanded than when you don't have the expanded. But with practice, you'll understand, why you need 2 and why you need 3 every single time you do that. But here I have my condensed structural formula, which works just as well. And actually, that's why I draw most of the times, just because this is a bit of a waste of time, especially if you don't have to do that. If you just want to see the general idea of where things are placed, condensed structural works better. So I might do that for the next few examples. So in the next video, we're going to finish off the last few examples of drawing, but make sure you can do these ones before you move on to the next video.